All right, so in this video, I will be talking through pages 17 and 18 in the notes packet. This is where we're going to actually start drawing Voronoi diagrams. So we've been kind of talking about them, analyzing them. That's what we did most recently. Now we're actually going to talk about how you would create one on your own. Now, it's important to note that you will not actually be asked to create one on your own on the exam. It would probably be too time-consuming. But you are definitely going to be asked to analyze them, and you might even be asked to fill in a missing part of it. It might show you a Voronoi diagram that's missing one edge and ask you what's the equation for that edge. So you do need to know kind of how you would construct them. So we're going to start with this fact over here, that if we have two sites, A and B, and we want to divide space in all of the points closest to A and all of the points closest to B, we know that dividing line is the perpendicular bisector of the line segment that connects them. So all of these points are closer to A than B. All of these points are closer to B than A. Here's the line segment between them, and we can see that that perpendicular bisector splits space evenly between the two of them. And so that's exactly where we are going to start with constructing our diagram. So we're going to do that in example 1 over here. First thing, there's a typo down here. It says 1, 4 for site A, but we see up here that site A is actually at 1, 3. So either way, we have our two sites, one of them at 1, 3, one of them at 4, negative 3. And we want to construct a Voronoi diagram to, so that's A and that's B. We want to construct a Voronoi diagram for them. So we want to find the midpoint of the two. And you can either do that visually, or you can go ahead and use your formula. So that's going to be 1 plus 4 over 2, comma, 3 plus negative 3 over 2. And that's going to become 5 over 2, comma, 0 over 2, or just 5 over 2, comma, 0. And visually, that's going to be right there. And that looks pretty spot on. All right, so now we want to find the equation for the perpendicular bisector. And so we know that the perpendicular bisector through that midpoint, we need two things. We need the midpoint, which we just found, and then we need the slope of the perpendicular bisector. And that's going to be the opposite reciprocal of the slope that connects these 2 points. So if we look at that, our change in y, so let me draw in that line segment first of all. So we have this line segment that connects point A and point B. And the slope of that line segment is going to be negative 2 because we have a change in y of negative 6, a change in x of 3. So negative 6 over 3 means that our M1, our slope of that segment, is negative 1/2, meaning the slope of our perpendicular bisector is going to be positive 1/2. So now we have y is equal to 1/2 x plus b, right? This will be the equation of our perpendicular line segment. And we know that it runs through this point 5/2, 0. So I'm going to go ahead and plug in 0 for y. And that has to be equal to 5 over 2, no, 1/2. So 1 over 2 times 5 over 2 plus b. It means 0 has to be equal to 5 over 4 plus b, meaning b is equal to negative 5 over 4. So our perpendicular bisector is going to have the line y equals 1/2 x minus 5 over 4. And we can go ahead and draw that in. So it's going to be right there. That's going to be about 1 over 4. And then we can kind of use our best judgment here, going over 2 up 1 to draw in that bisector. And it's going to be right here. So this line is going to divide space where all of these points in orange are closer to point A than they are to point B. Whereas all of these points down here are closer to point B than they are to point A. And so we've constructed our Voronoi diagram by finding the perpendicular bisector of the line segment that connects the two sites. All right. But sometimes you might have more than 2 sites, right? What if you have 3 sites? And we're still going to do the same thing. We're still going to find the perpendicular bisector of the line segment that connects the points. In this case, we have to find 3 of them because we have essentially 3 line segments that connect points, right? We have AB, AC, and we have BC. And we find the perpendicular bisector of all 3 of them. But as you can see, you only use part of those perpendicular bisectors. So we have this perpendicular bisector AB, but we stop there, and all of these points over here are not included. And the reason why is because if you're at this point here, right, it is true that you are equidistant from A and B, right, because you're on that perpendicular bisector, but you're even closer to C, so it doesn't matter. You're just going to be in cell C. So that's the added part here. And we're not going to deal with when there's more than 3 sites. That is just too time consuming. So we are just going to stick to the 3 site case. And we're only going to do one example of that over here. So we're going to start by graphing sites A, B, and C on our graph down here. So A is at 1, 1. B is at 7, negative 1. So I can label those A, B, and then C is at 7, comma 5. So C is right there. All right. So our step 1 is we're looking at the line segment AB. And we want to find the midpoint of AB. So the midpoint of AB is going to be at 1 plus 7 over 2, comma 1 plus negative 1 over 2. It's going to end up being at 4, 0. So that midpoint is right here. So we'll call that M AB. Maybe if I can write small enough, we'll call that M A B. Okay. Let me actually do this with color. I think that will potentially be helpful. So let's draw in this line segment AB with red. Highlight that point there. And then again in red, label this M AB. Okay. All right, so now we want to find the perpendicular bisector here. So we want to find the slope of the original line segment, which is going to be negative 1/3. As we go over 3 down 1, meaning that the slope of our bisector is going to be positive 3. So it's going to have the equation y is equal to 3x plus b. And if it runs through this point 4, 0, well then we have 0 is equal to 3 times 4 plus b. 0 is equal to 12 plus b. B is equal to negative 12. So our perpendicular bisector is going to be 3x minus 12. And I'm going to go ahead and graph that. So that's going to be, we're going to start there. And then we're going to go up like this. Oh, I did something wrong. I skipped the point. That's what I did wrong. Oh, it's going to go something like this, right? Starting at negative 12. Going up 1 over 3. And I'm going to start with a dotted line there. So this is our perpendicular bisector. I'll fill it in later. We just want to note that we might not need the whole line here. So let's start by just doing a dotted line. All right, and then we want to do the same thing with AC. So we want to find the midpoint of AC. So I'm going to start by drawing in that line segment, now in green. And now let's figure out the coordinates of that midpoint. So that's going to be at 1 plus 7 over 2, comma 1 plus 5 over 2. That's going to end up at 4, comma 3. So then we will add that midpoint in there, 4, 3, and then we'll label that midpoint AC. And the slope of the line between these two, well, we see that we have a rise of 4 and a run of 6, meaning that that slope, that M1, is 2 over 3. And so if that M1 is 2 over 3, well then our perpendicular bisector, M2, has to have a slope of negative 3 over 2, and it has to run through 4 3s. So that means it's going to be y is equal to negative 3 over 2x plus b. That means that 3 is equal to negative 3 over 2 times 4 plus b. 3 is equal to negative 6 plus b. B has to be equal to 9. So the slope there, or the line there, is going to be y is equal to negative 3 over 2x plus 9. Right, now let's go ahead and graph that. So we start at 9, and then we go down over 2 down 3. And so this is then going to be the slope of that perpendicular bisector. Once again, I'm doing it in a dotted line so that I can figure out which part of it I need later on, because I might not need all of it. And that just leaves us with CB, or BC. So I'm going to draw that line segment in like this, in blue. And then we want to find the midpoint there. So the midpoint of BC is going to be located at 7 plus 7 over 2, comma, negative 1 plus 5 over 2. And that's going to turn out to be 7, comma, 2. So we're going to go ahead and add our midpoint right there. We're going to call that MBC. And if you notice, that is a vertical line. So the perpendicular bisector, or the line segment itself, doesn't have a slope. But we can use our judgment and know that the perpendicular bisector therefore has to be horizontal, right? If that's vertical, in order to be parallel or to be perpendicular to it, we want to have a horizontal line. So for the perpendicular bisector, I'm just going to draw a horizontal line through that point. So now we have all the information we need. Now we just need to clean it up. So let's identify the vertex. The vertex is going to be right there, right? That's our vertex. And so now we want to, it says erase the extensions. I'm going to do that by kind of drawing in the part of the graphs that we actually need. So that's going to be, if we see here, these are all of the points that are equidistant to A and C. These are all also equidistant to A and C, but they're closer to B. So these are the ones that we don't need. These are the ones that we do need. So I'm going to kind of take my pen and I'm going to fill in this part of this line, make this solid. Okay. And then I can kind of erase the rest of this to clean it up. All right, and I'm going to do the same thing for the red one, noticing that these are the points that we need, right, because the red one is AB. So all of these points up here, yes, they are equidistant from AB, but they are closest to C, so none of these matter either. And then finally, we want to do the same thing for MBC. That is right here. Because all of the points over here, yes, they're equidistant from B and C, but they are closer to A, so it doesn't matter. And that is what our Voronoi diagram is going to look like. So now I'm going to kind of highlight that these are, right, these are your points that are closest to site C. These are your sites that are closest to site B, and these are your sites that are closest to point A. All right, so a little bit of a kind of tedious process there, but the good news is you'll never have to do that whole thing in its entirety, but it's important that you understand at least the logic of each step. So if they ask you to find a missing edge or determine the location of a vertex or something like that, you have a way to approach it.